Welcome back, Math 10s. We're going to finish off this trigonometric unit with some slightly more challenging questions, problems that involve more than just one right triangle. So over here, we're just going to do two examples here. We're not learning anything new, but I'm going to mention a couple strategies that should make this easier. We have two right triangles. They are kind of stacked on top of each other here. You can think of, I have a right triangle here of A, B, and D, and then I have another right triangle of B, C, and D. And the question's asking us to find the length of side CD. So here is our X. We do not know this side. Okay, how could we do this? And the idea to determine when you're missing a side, you start looking at one triangle at a time and determine, hey, is there anything that could help me find this side? Now, we don't think Pythagoras would work, of course, because I would need to know the other two sides. So that's not going to get me anywhere. The sum of the angles, I could use that to fill in some of these missing angles, but again, that's not telling me what this side value is. So if I look at the current triangle that it belongs to, I only know one thing about it, and it's the fact that this angle is 26 degrees. Now, if I wanted to find this side, what ratio could I use, or what trig function? I have so, and I have ka, and I have toa. So I have two choices. If this is my angle, let's quickly label triangle. This is opposite. This is the adjacent side that I'm trying to figure out, and this would be the hypotenuse right here. Okay. Now, if I knew the opposite, okay, if there was a way I could find the opposite, I could find A using the tangent trig function. If I knew the hypotenuse, I could then use the cosine trig function. Okay. We can see here that sine is really not helpful because that doesn't even involve the adjacent side at all. Now, which one makes more sense? So you want to ask yourself, can I find the hypotenuse or can I find the opposite using the other triangle? And to find the opposite, we see that this side is not shared. It is not part of the other triangle at all. So that makes it much more challenging. The side that these two triangles do share is this hypotenuse. It is actually the hypotenuse for both of the triangles. So let's see if we can determine what the hypotenuse is. Then we know we can finish off the question by determining x using the cosine trig function. Okay, now how could I find this hypotenuse? So let's change colors and label this other triangle. I know one of these angles is 47 degrees, and I do know the opposite side. Here's the adjacent, and the hypotenuse is the same, so I'll just still label it there as h. I do know the opposite, so we can determine this shared side. We can find the opposite easily because I know the opposite and I want to find the hypotenuse. We're going to use the sine function. So what we're doing first here is find shared side. And in this case, it's this hypotenuse, the shared side of the triangles, which is side BD in this case. Okay, so we can do that easily. The sine of 47 degrees is equal to the opposite over the hypotenuse. The opposite is 4.2, and we're going to divide by h. Now remember our strategy here. We can do a quick shortcut and swap these two things, skipping the algebra steps. So the hypotenuse is going to be equal to 4.2 divided by the sine of 47 degrees. So h is equal to, in this case, 5.74 and some more decimals. Now, keep those decimals. Keep the decimals. In other words, don't early round. Okay, leave that number with some extra decimals. You don't need to keep 20 of them, but just several of them will do. And now we can use that shared side to use the cosine function. because now we're going to use the cosine of 26 degrees to figure out the side the question was asking for, this side that we just called x, which is the same as CD. So x is the adjacent, and we do know now the hypotenuse. We're going to enter in that number with some extra decimals, 5.74, and we can now determine this missing side. Now remember, our strategy here is simple. We're just going to multiply both sides by that 5.74 and this side by 5.74. And this is going to give me my result to determine x, because those cancel. And when I multiply 5.74 times the cosine of 26, I get 5.2 centimeters. So this is where you finally do round at the end. So little note here, round only your final result. This will save you any little rounding errors by accident. Okay, so what did we do? We figured out by working backwards, I want to know this side. I don't have enough information yet, but by looking at this triangle, I knew I could find out the piece of information, the hypotenuse, to help me determine my missing side using our trig ratios, our trig functions. Let's try another one here. So here's our diagram. You can see I have two triangles, and it's asking us to find the height of the taller building. What do I know? I know the height of the short building. I know the angle of depression, the angle of elevation from the top of this building. So you can see how we're getting two triangles. Okay. So I need to determine the height of this building. So I need to know both of these sides. I need to know, let's label this. How should I label this? Let's call this x1, and let's call this x2. I need to determine both of those distances, or those heights, sorry, and I'll be able to figure out that the total distance here is just x1 plus x2, whatever those two numbers are. Now, do I know any of them right away? Let's take a look at this. Well, the 20 over here is this distance on this side. And because everything is parallel, that we have the horizontal with the ground, the horizontal with the building, that tells me that I can say, well, this must be 20 meters. Okay, so that seems pretty easy. We found one of them already. So x1 is 20. We need to figure out this missing side right now. All right, well, we know a couple angles. Okay, we do know this angle is 30 degrees, and we know this angle is 15 degrees. Again, let's work backwards. I need to determine the x2. I need this distance, and then I'll be able to finish off the question. Well, I know this angle, okay? And so in reference to this angle, let's draw this over here. I'm going to draw this triangle over here. This is 30 degrees. And so this angle is what I'm trying to find. This is my x2. But if we were to label this, this is the opposite side to that angle. Here's our hypotenuse, and here's the adjacent side. Okay, now the hypotenuse, would that help us? So right now, I don't know anything but this angle. I need another side so I can actually use one of my ratios, because this is the opposite. And so if I look at SOHCAHTOA, SOHCAHTOA tells me which possible trig functions could I use? Well, the only one that's not applicable is actually going to be sine, because I don't know the hypotenuse. Okay. Now, cosine's actually not helpful either, because I also don't know the hypotenuse. I don't know the adjacent side, but this doesn't even have the opposite side included in its ratio. So this isn't going to get me anywhere. Possibly TOA could work, but the problem still is I don't know the adjacent. I need to find the opposite side, but I don't know the adjacent. But we do know some information about the shared side with this other triangle down below. And since we know this side, okay, so here's our other triangle. I'll do in blue. The triangle down below, we do know that this is 15 degrees right here. And we do know this side is 20, so we could find out its adjacent side. And if we can find this adjacent side, I'll have enough information to solve for x2, for the opposite in my bigger triangle. So let's do that first. Let's figure out this A. So this A is going to be determined. Let's just erase that. To find that A, we're going to use tangent. So the tan of 15 degrees, because I know this is the opposite, this is my hypotenuse, this is my opposite side, so that's going to tell me that this is 20 divided by the adjacent, which is A. We're going to use our trick where we just swap these. When we swap those, we get a new equation to determine that A is 20 divided by the tan of 15, which tells me that this side is equal to 74.64 meters. Okay, so that tells me this is also 74.64 meters. All right, we're ready to solve the x2 of this question, because to find x2, I can now use the tan ratio again. So let's go back over here. We're going to find now x2 by determining we take the tan of 30 degrees this time is equal to the opposite over the adjacent. So opposite is x2. Whoops, not x squared. Okay, so let's just do that. Okay, put a little 2 here. We can solve for x2 divided by the adjacent side, which is 74.64, keep some extra decimals. And now we can easily just multiply both sides by 74.64 and 74.64. Those are going to cancel. I'm going to take my work down here. Apologies, I'm getting a little tight for space. So I can find that x2 is equal to, when I multiply and use my calculator, we're going to determine this to be 43.09 meters. Now remember, I do have to add on this x1. I want the total height of the building. So therefore, total height is equal to x1 plus x2, which is equal to 20 meters plus 43.09 meters, which is going to give me a total height of 63.1 meter when we round to the nearest tenth. So there's our total height of the building. And that concludes the lesson. We'll see you in class to finish off this unit.